Hello everyone, I'm Meghna Singh, MTech Data Science student, is here to present a literature survey on my MTP thesis titled as Topic Modeling over Short Text. So let's start the presentation. Like in recent years, we know that social media networks have emerged as a main channel for expressing the opinions or sharing of ideas or discussions over a topic. And even if we see that in the elections, political elections, which happened between US and India, a lot of political parties are taking expressing their opinions using Twitter as a platform. So this was the basis of our thesis that we are here to propose to provide a comprehensive study over various approaches which are being used to extract the topics which are discussed on these social media platforms. And since we know that this is an active area of research and a lot of knowledge will be exploited from the copious amount of data which is collected, which pertains to the student behavior of the users in the online environment. So this is of utmost and critical knowledge to us. So why we are particularly focusing on short text, because short text has a limitation in the size and the word limit. So the standard traditional algorithms that are existing, a lot of algorithms already existing, they tend to work very well and perform very well on the large corpus data. But when it comes to short text, they don't like impress us with much good results. So here the problem is I'm focusing on since Twitter data. So let's say that every tweet will belong to a single document. So here and here each in the thing like document you can see, and they are assigned a particular topic. So initially, what happens to the model? Everything is completely aware because the model is not familiar with the pattern of that text corpus it has been fed into. So we will assign the random topics to every document initially, and by the end of the finally when a model will be executed and we will get the optimized result, will be assigned every tweet or every document will be assigned a particular topic. This is actually the overview what we are trying to do. So here the content wise I've divided into 5 sections with the introduction, short text modeling approaches, performance metrics, and the performance proposed a framework on one of the existing technique which is discussed in section 2, and then the conclusion of future work we'll be discussing, and we're not going much in detail because of time constraint. So section 1, motivation, we have already discussed why we're doing this. The topic model, as we know, it works in 2 action phases. That first is tries to discover the topics, and then for every document it will try to assign the topic to them. So it's like a computation problem to us. We are given some input, which is a text document, vocabulary set, and the k value of the topics is either hypothetical, we can take it as threshold value, or we can specify clearly that we want k topics. And in the output, what we want, a distribution. So it's actually a probabilistic model. So it works on the distribution. So we want a word distribution where word distribution corresponds to topic and topic distribution correspond to a word. And since they belong to probabilistic approach, so they have to sum up to 1. Why I'm saying this? Because let's say we have a document here and there are multiple topics, because every word you can see there belongs to different colors. These colors actually correspond to different topics in a single document. And we can say that this single document has a mixture of topics. And even if you see the pink color topic has multiple words, we can say that a topic belongs to a mixture of words. So that's what I wanted to say actually. And if you see that that is a probabilistic distribution, because every word will be assigned a probability, and since theta 1 lies here is a topic and this is a topic, another topic, travel, and there will be the words assigned. So it forms a word distribution out of here, and these word distributions will form a topic, and this topic distribution form a document. So this is the background approach we need. We will consider our approach as a generative model, and we will use a Bayesian inference and parameter estimation techniques to do that, to estimate our results. So going to the section 2, we will be discussing the 5 techniques which we have discovered over the survey. So like a latent derivative allocation is one of the standard one, and then the key means and the biterm, and we'll just have a look on them, not much into details. So like latent derivative allocation, the primary thing is that it assumes that like what we have already discussed, it assumes that a document belongs to multiple topics, like here, and a topic belongs to multiple words. So this is it forms a fundamental, and LDA, latent derivative allocation, is a fundamental to every topic model. Then the k-means clustering. K-means clustering, we have the clustering techniques. Like we cluster the documents according to the topics. So this forms how k-means clustering works. So every topic, but the only difference with the standard model LDA is that here, unlike LDA where every document can belong to where every document can have multiple or mixture of topics, Here, every document will belong to a single cluster, because cluster is a topic here. A document cannot belong to multiple clusters at a time. So this is the only difference. Then we have the bitem. Yeah, for the short text, k-means works not good enough, because we have to explicitly specify the value of k here. But when it comes to practical implementation, k value, since it is all hidden, we don't know what actually number of topics we have. So specifying the value of k particularly is not a good thing. So that's why we don't prefer k-means, because of the specification explicitly value of k which we have to give. Then we have bitem topic model. In the bitem topic model, like instead, like in LDA, we are discussing on the words. Like here, if you see, yeah. So here, if you see, every word will correspond to a single topic. So every, like here in the word, if you see the third word, it belongs to a yellow topic. So in this bitem, we club the two words together so that we can form the occurrence, co-occurrence in the words. So it's a co-occurrence based methods. And then we have self-aggregation method, where we combine the small documents and form them into a large corpus. So in this self-aggregation based method, we combine a small corpus of documents into a large corpus, and then we apply the standard modeling algorithm like LDA to them to work and get the optimized result to us. And then we have the most awaited one, which is the Gibbs sampling approach. It is actually the one which we have focused to work on ahead. Why? Because it is actually similar to what the LDA is. The same probabilistic approach it uses. Actually, they all use probabilistic approach. The only difference is like in k-means clustering, it specifically says that every document will belong to one topic. Yes, it is the same approach here. Every document will belong to one topic. Why I'm saying this? Because since like we have a tweet, the tweet length is small enough that it is very highly unlikely that it will be discussing about multiple topics at the same time. It is not likely possible. But in the large documents like this, there's a possibility that they can discuss multiple topics at the same time. But in tweets, we specifically say that they discuss about one topic at a time. So we say every document will have one topic instead of saying multiple mixture of topics. That's the only difference. And the topic will have a word distribution is still the same like in LDA. So this is how GSDMM differs. And for k-means, GSDMM is very good. We have observed the results and we found that it outperforms LDA when it comes to short text, and this is a very good approach being used, and the variants of GSDMM are also being used extensively, but still an active research is going into this part. And one of the question might click that what is the difference between k-means and GSDMM? So like in k-means, I specifically said that we have to mention the value of the k. But since everything is hidden to us, that we don't know the topical structures because they all are latent. So specifying the value of k is not a good idea. So what we do in GSDMM, we specify a threshold value of k, and then we proceed. And that's what that and then with the iterations, it gets to the optimal value. So this is what the fact is. And what should be the value of k? We don't need to worry about in this. We just specify some random value, and if you see that get optimized ultimately. And here number of iterations which are feasible, we can specify around like these many iterations, and you can see the behavior of the number of clusters being formed. So then here we have the performance metrics section, where we use a topic quality assessment evaluating technique to get the outcome of the results. And we will be discussing, I thought of discussing it in the direction like problem statements and data set and modeling, but since because of the lack of time, I cannot go into much of the details, so I will just have an overview. So like topic interpretability is about how like humans can infer the topics very well. I mean, they have the domain knowledge of it. We just read the things and we can relate them, okay, because we have the semantic knowledge. Okay, this even if the exact word is not there, we can relate to the context. But this is not with the models which are currently existing. So topic interpreting, how easily the topic model interpret the topics, and human can interpret the topics in a very proficient way, but topic models as such cannot. So we use the different techniques like robustness. Robustness actually talks about how relevant that particular word in a topic is, and so like various techniques which actually describes about interpreting the topic at its best. Then we have perplexity, which tells how good the model is, how best fit the model is. Then we have precision, recall, and F-score. These are the metrics. And topic coherence is the main matrix which we are actually focused, because it tells us about quality of the topics. Then we have homogeneity and we have completeness. So I have actually given this analysis for all of these, but since because I said time shortage, I cannot go much into the details, and this is everything the survey which we have done over the period of time. So now we come to the section 4. Section 4 part of the of our presentation is actually the proposed framework which we are actually the idea which we are proposing. So what the main thing which we are looking for is we have the GSDMM. We formed the GSDMM as our basis. GSDMM, we are trying to improve this model. So the like I said, when we were discussing about topic interpretability, like humans have the contextual knowledge, but the basic models don't have. So we are trying to provide those context knowledge to the models so that they can relate the context even if the actual word is not present. So even then they can relate the word and the semantic meaning out of that and can give us the results. So semantically identifying the context. So there are many databases, or we should say ontologies are present, which are called concept-based ontologies. So we are trying to inculcate those ontologies into the model so that we can improve the quality of the topics which are extracted. So in the very basic model of GSDMM, there is no ontology concept here. So if you see on the left side on the AF figure, you see that for every document we have a mixture of topics, and for those topics we have some certain amount of words, distribution of words. There's a direct linkage between words and the topics. But when in the approved model you can see there's some concept inculcation into the proposed into the model, which actually means that now topics are taking help of the concepts, and these concepts are helping us to determine the words, and then they will form the basis. So words will now form will go to the context, and context will go to the topics, and they will give us better results which we expect. So this is a proposed model. So actually we have the GSDMM model, and we have tried to inculcate this concepts into the C, and it's a concept. We have tried to involve this concept into the model. The detailed analysis of the work is actually explained well in the report of the thesis, but I have just tried to cover them in a very basic level. So for this data set, we are trying to cover two data sets here. One primarily being used in one of the paper which I have surveyed. They are using this weather corpus data set. So this weather corpus data set, so they have actually tried to use this weather corpus data set for comparison between LDA and GSDMM. Now we will try to use this data set to compare between GSDMM and improve the GSDMM, so we can see the results, how they are varying. Another data set is the Sentiment 140 data set, which is actually publicly available. It consists of 1.6 million tweets. It's a large data set, and the thing is, it is annotated, it's a label. So we can actually, after the topic extraction, we can easily classify the results, and we can easily like check the accuracy of the results. So that's the purpose of this model data set. And finally, we are to the conclusion part. So what I have to conclude is that we have done a comprehensive study on these modeling approaches, and we have tried to conclude that GSDMM outperforms LDA for the short text data, since LDA is the fundamental algorithm, that many variant of LDA like GSDMM works very well for the short text data. And since short text data is of emergent need, we will be focusing our research work on to GSDMM and its improvement only. And for the future work, we have tried to actually propose a modified model of GSDMM, so the future researchers can actually be more aggressive to make better changes and improvements, so that it gets better quality of results, and we expect to give better quality. We do expect to give better quality results. And in the last part, yeah, the major challenge I felt throughout the survey was that it was very difficult, to decide which data set actually, when we have a random data set, I am not sure which technique I should use in order to work on this data set. This is really a challenge. I'm still not sure, and this is an open area of research. So the future researchers can also look into this direction, that because the data set, I mean, we are not sure that for which algorithm will suit the data set. the best and which algorithm will give the best result on this data set. So this classification idea is not yet cleared. So future researchers can look into this work. And with this, we come to the conclusion and end of the presentation. So thank you so much.